to give an overview, this is an old prototype project from about a year ago, right around the same time that I was working on early VR prototyping stuff with Nick Donaldson before we started doing bullet train stuff, and just got some time to make it a little bit more polished up and showable a couple weeks ago. So we just wanted to show as kind of a quick example of how you could do some interactions with motion controllers and set up a very basic pawn hierarchy. So part of this, what we have right now working is just a real basic bow and arrow. You have the string, you can shoot, and the shot velocity is based on the tension, which is just defined as a exponential gradient based on how long you pull the bow. So as you can see, a tiny pull will kind of just fall limp, whereas it'll quickly get up to about a maximum of around, I think, 150 feet per second. So this was calibrated to be similar to a standard longbow. And of course, there's no art assets or anything for the project right now. It's just everything here is made out of meshes in the engine folder, like cones and cubes and stuff like that. But so there's a little shooting gallery that is basically a classical increasing difficulty ramp where you have a certain number of lanes. Right now there's 10 lanes, and it will randomly spawn targets. You see that fading scroll bar or progress bar. Whenever it gets to 0, another target will spawn. And it's basically going to start filling up the lanes and get faster and faster. So each successful shot will increase the speed of the targets and decrease the interval. So it's meant to get about impossible after about 2 minutes. And there's a couple little things in here that are kind of neat. We'll see if Wes can get a perfect bullseye. There you go. So when you get a perfect bullseye, you actually get 3 arrows. And it's easier to use them at the end when there's more targets.
Yeah.
There you go. But just showing how you can do some simple little things like that with blueprint interactions. So this was a fun little project, and then Wes added some cool features in a separate little demo. He made kind of a tower defense horde game with some Infinity Blade assets. So we'll show that after we show the structure of how things are set up and just kind of go through a mini tutorial session.
Yeah.
And it's set up so that you can grab with either hand, or at least it should be.
Yeah.
I'm sure there's a couple bugs here and there. Seems to be working all right.
Ambidextrous.
So we'll go over, how it's using the motion controllers and in different hand blueprints to be a little bit easier to script. And you can see he's just about filled up all the lanes with walls, which it doesn't actually fail you right now, but the thought was maybe after you get 3 of those walls up, that's a fail condition. And we would have liked to add a high score system or something like that, but didn't quite get time to finish it.
Yeah, I think we would spend most of the time kind of breaking down the mechanics. I know that's what a lot of you guys are interested in. You guys can then build around that once you have the idea of how the mechanic was constructed.
Yep. So jumping right into the blueprint structure, give me 1 second to pull up the content browser. And so you can see in terms of the project, it's pretty basic. We have a gameplay and a weapons folder. In the gameplay folder is really just the character and the hands. So the character is the pawn, and the hands are blueprints that control the interaction for the left and the right hand. And there's a couple reasons you might want to do it that way, especially when it's a state-based system like this where you have 2 hands that essentially do the same thing. And if you did all of that logic in the pawn here, which you certainly could do, you'd end up having 2 copies of all the variables, like a left grabbed actor or a right grabbed actor, and you'd be juggling the states. Whereas when you do it with a blueprints that are instances of each other, they both kind of behave the same, and they can be kind of aware of each other. And so kind of show you how that works right now. So the pawn is dead simple. This is the whole script of the pawn. Really no scripting going on here. Show you on begin play, we set the tracking level to floor, and all that does is make this work the same between Oculus and Vive so that they're both tracked at the ground level. And then it does register the hand blueprints. And I'll talk about the structure of the pawn here first. You'll notice we have first up a scene root and then a capsule. And the capsule is just defining how tall the player is going to stand. So I have it, capsule height is around 96, so the character is around 200 centimeters tall. Some notes about how this is set up with the camera. All you really have to do to make an HMD camera is you add a camera to the pawn, and we'll have lock to HMD as an option there. You see that option, lock to HMD. That means it'll follow the camera. But you want to position that at the bottom of the pawn, which is why here we have another scene root, which I've renamed to HMD root. And I've moved that to, what does that say there? Hang on. Oh, actually I'm using this additional root in between. So this is at -96, which puts it at the bottom of the capsule. And the reason for that is that you can't move the capsule, or you want to keep the capsule at 0, 0, 0, and then just offset your root to be at the base of that for the Vive. and then the camera can be just relative to that 0. So now the camera will, wherever it is, will be relative to 0 of the pawn's feet, rather than 0 of the center of the pawn, which would put you too tall or something like that. So pretty much all we have is some scene roots and then a camera. And then underneath this same, let me hide the HMD, we have left motion controller and right motion controller. And those are really the only other 2 key pieces that you're going to have in a VR setup that'll pretty much always be there. And these are, you just add them here, left motion controller, or sorry, it's just called motion controller here. And I'd rename them to left and right manually, and then make sure that you select the right one. You see this one is set to left, this one is set to right. And that's pretty much all you need to do for the motion controllers. And notice that I've added child actors. So underneath each motion controller is here's a left-hand child actor and a right-hand child actor. These are both just child actors added by doing child actor. And then we've specified them to be BP left hand and then BP right hand, which is a class of left hand, so that there's no custom scripting going on in there. And then text render, this was just a debug thing I put in here to make sure that the height of my head was about where it should be, because it's easy to mess up by having missing scene root or something like that. And it's actually on, which we don't really need it, so I'm going to go ahead and set hidden in game right now so it doesn't show up again. So that's pretty much it for the pawn structure. You'll notice here in the tick, this was that debug I'm talking about, just wanted to show the centimeter height of the head in the world, or actually this was the local tracking height, and just show that, not really needed. So the only real script that's happening here is we have motion controller left grip and right grip are hooked up to pass some input to the left hand blueprint and the right hand blueprint. And all they're saying is grab and release. And that was just done that way so that I'm not worrying about consuming input or anything like that. You could probably have done that in the hand blueprints themselves, but that gets trickier because then it would have to be separate left click, right click inside these, which would mean the script is no longer agnostic inside the hand blueprint, which you want it to be pretty agnostic. Like whatever's happening, it doesn't care which hand it is, it just knows what hand it is itself. And so the fact that these left and right hand blueprints are here, notice we have variables down here, and that was done because you don't have access to all of the properties of a child actor without casting to the class, which is a bit of a pain. So I'll usually do that ahead of time, which is why in the very top here you'll have register hand BPs. And all that's doing is taking these already created left and right child actors. It converts them, it gets the child actor, because otherwise you can't cast, which always is a little weird to me, but I've just accepted it. And so we cast to the left hand type, and then we store that left hand as the left hand BP. And now if we want access to it, we could, tell it to grab or do different stuff, and we have access to all of its properties. And then same thing for the right, set it to be the right. But notice the right hand is still of class left hand, which is why they're both the same class. And one other little note here, inside of my hand blueprints, I have a property called other hand blueprint. And I go ahead and just, for the right one, I set the other hand to be the left. And that means that they can communicate to each other seamlessly as well. And for the right hand blueprint, I set it to be the left.
And those are properties you just created inside of the left hand blueprint. And you're passing those through at this point.
Yeah, sorry, I said that backwards. It's telling the left hand that the right hand is the other one. So that's all that does, is it basically tells them about each other and makes the pawn have easy access. That's so far the whole pawn for this project. So we don't have any movement or anything fancy like that going on. So the hands are also pretty simple. There's really no script in the right hand, it's just an instance. So in fact, if we open it, notice it's just like a data-only thing with nothing changed, other than one setting, which
the very top is left hand?
Yep, is left hand. So that was the one thing that was changed in the left hand blueprint, in the right hand blueprint, and I'll show you how that works now. So this is the left hand, which is controlling all of the interaction for this. And you can see it's pretty basic. All it does is handles grabbing and overlap. So let me see here. The grab and release functions are over here, where they basically do some logic to communicate to the other things that you want to interact with. So I'll take a quick second right now to talk about why it's using that. It's using actually an interface. And interfaces are not super popular anymore because they're a bit of an older method of blueprint communication. that was created before you had the ability to communicate directly between blueprints. But it's still useful in cases like this, where you want to do the same kind of action over and over again between possibly many different blueprints. And you wouldn't want to go through the trouble of creating these functions and always adding in a input for which hand, what am I doing, did I drop it? You know, you'll spend so much time refilling out that information if you don't have an interface. So I've created an interface to do that here. And it's probably worth really quickly looking at the interface before going into too much how the hand itself works. It's a pretty simple interface, so don't worry. So we're going to go down here and back into gameplay, core, interfaces. And most of this stuff is just little, you know, helper like a macro and some material functions. There's not a lot in here. It looks like a lot of folders, but that's mostly because this was migrated out of a different project. So we're going to look at the player interaction interface. So this is when you first create an interface, there will be nothing here on this functions list. Then you add a function by, you know, adding function and adding in whatever new stuff you want to do, you know, add in functions like that. And then once you add those functions like that, they'll show up here in this list of interface functions. And just a little thing, I'll tend to, even if I'm not using any variables, add some kind of return variable, even if it's just blank. Let me see if I can, yeah, you see here, this is one hand end overlap. I just have this blank no name variable here, and the only reason I do that is if you have a return variable, the interface functions will show up in this list. Otherwise, it's just expected that you have to actually create a node in the event graph for it. And I feel like that's not a super great workflow for me. So I like to have all of them here and just know what's being used. So I'll make sure they all have a return function. But generally, they are all pretty similar. And they're all just kind of passing basic input from the motion controller. For this one, all we're really using is grab pressed and grab released and hand begin and end overlap. We're not even using the trigger for this project. So I'll just show you guys those. So all we really care about for grab pressed is which hand. And that's actually an enum of left-right. And all it tells you is it the left or the right hand. And we have some other options, like was it dropped on release. And for grab pressed, it's similar. We have which hand, but we also have a reference to the hand blueprint, which is useful because when you grab the bow with the hand, you want to tell it what was the component to attach it to and you know, that sort of thing, or where is the sphere so it can check overlap. And there's some return options, such as the transform of the object, the hand, and, or sorry, this could be where you return the transform of the object that's being grabbed, whether it was picked up or not, whether it was a secondary grab. And also, this is another option, local grab position, which isn't used here, but it's useful for if you wanted to do something like grab a staff and it had to be grabbed in a certain place. You could transform that hand to a local position and then adjust it as necessary and return it. And then the begin and end overlaps are pretty simple. Begin overlap basically, again, has the same hand blueprint and which hand, so it's left, right, and a reference to the blueprint. And then it also passes in a selection material instance dynamic, and that's to make it easier for the hand to highlight if you have a preview material that glows or something, which we're using on all of the bow and arrow stuff, like the knock will glow when you're going to knock an arrow, or the string will glow when you're about to grab it. Or sorry, I said that backwards. When you grab it, the knock will glow by your hand, and when you pull the string, there should be something by the string that glows. And it's able to just pass different instances in here, and then it can work without having a separate action for every type of material, for example. So that pretty much goes over that. It's just a way to pass in all this information to all, like if you added new weapons, you would just reference this interface. And for those of you who are not sure how to add an interface, it's down under class settings on your blueprint. You go down to implemented interfaces, and you can see I already have my player interaction interface, but we could go ahead and add a different one, which I won't do because I don't want to risk messing it up.
Yeah, no, but what's great about using an interface, it doesn't care what it is you're picking up. It just passes that information through, so you don't have to specify what type of object I picked up.
So
it's pretty clean.
I guess that's the bow. For the hand, I'm going to go back to the event graph. And rather than talk about the grabbing yet, first I'm going to talk about the overlaps, because that's kind of the precursor to grabbing. So we have here, you notice that my hand has a sphere, if I can get closer. It has a sphere collision. There it is. And that is set to overlap all. It doesn't block anything. But it's useful for figuring out if you have overlapped some other component. We'll go back to the event graph. So basically, the way you add events for that, let me bring up the settings. Oops. Sphere. If you go down here, you can add events. There's already one on component overlap, so now it's a view button instead of an add button, right? So that's how you add those, just to not glance over anything. So there's a couple little logic things that happen here, which are just to really avoid spamming the system and avoid confusing. So we have a little macro here, is other hand BP. All that does is make sure we don't ever do any overlaps with the hands overlap each other, which you'd think you wouldn't need to do that because you should set the collision profiles to avoid it, but it's better just to check it. And all it is really, is it not the other hand blueprint? Yes or no. You know, that's simple. All. It's a macro that just checks that for you. And then the other thing is we want to make sure that we're not already overlapping something, so that helps avoid, you know, fighting over things. Technically, you'd probably add some sort of priority here, which I think is what Nick did for Bullet Train, but right now this is basically assuming when you overlap something, you can't overlap something else until you've ended that overlap, either by grabbing and dropping or whatever. So it's saying, is it not valid, to make sure that it only happens if there's nothing there, and then it sets this actor to, overlapped actor. So you notice here's the variables we have here. We have the pawn, which is a reference to the pawn, which we get on begin play. Other hand blueprint, which is the reference to the other hand, whichever one that may be. And that was set in the pawn on begin play as well. And then this other one is left hand. This was the one that was added so that we can support having a right hand without changing anything. And it's set to is left hand true, and it's editable, which means it can be changed on the other one. It doesn't have to be exposed on spawn because we're not going to change it after spawning, but it could be similarly. And then, you know, these are the secondary grabbing things, which is useful for, you know, pulling the string. And so these things, overlapped and grabbed actor, is how it handles the state and how it makes sure it doesn't do grabbing multiple things at the same time. And they're both just an actor variable reference, as you can see up here. And some of these other ones are just little helper variables for grabbing things and transforming in the material instance array. So that pretty much shows most of those features. So at this point, we've overlapped something. Nothing is overlapped. So now we're setting whatever's being overlapped as the overlapped actor. I have debug text kind of spattered throughout here just to help. So you'll notice I have a function set debug text. All that's really doing is setting a debug text on the hand. Let me see. Yeah, it's probably hidden right now.
Yeah, just
where is it? So yeah, I do that just because sometimes it's ambiguous what's happening. And I'll add that so it says we overlap something. But you can ignore that for now. And so now this is going to do the hand begin overlap, which is the interface call to the actual thing you're overlapping. And you notice here we have that hand left right. Another macro, which hand am I? This is pretty simple. Doesn't even have any input. It's just is left hand, that same thing we saw over here. If it's not, then it's the right hand, right? It's pretty simple. So that's a quick way for both hands to work with everything without having two sets of, you know, like a left overlapped actor or blah, blah, blah. So it tells it that there was an overlap. And, you know, if the thing replied, which is a nice way to say not do a bunch of stuff in case something wasn't hooked up or didn't actually work with that interface. So then it's saying set the highlight MID array and then set the selection highlight. You'll notice here that this, I didn't actually update this to be an array, but it was programmed as an array in this blueprint so that you could actually pass in multiple highlight things if you wanted to. But it's just converting the one instance or material instance dynamic to an array. And then it just does the selection highlights, which this is pretty simple. It's just getting everything in the array, makes sure there's something valid there, and then it sets this selected parameter to 1. And you noticed before when I was showing you the content browser, let me see.
Undock. There you go.
Didn't realize it was covering up. Sorry. So down here in the material functions, we have this MF selection glow. I just added this to every single weapon that has some selectable part. And all it is, you know, a yellow color and an emissive. And you just drop that function in, plug it up to emissive, and then that material works with selection highlight. So that's the whole selection highlight color thing. So that shows the logic for when you have overlapped something. So I guess I'll go back into look at the bow real quick and show how it works on that side. So you can see here, begin overlap. So this is basically the other side of this. So this calls begin overlap to the hand, which is the overlapped actor, tells it which hand. And it's basically, the bow has some of its own variable states, which we'll go into this in a little bit more detail in a second once we're going to recreate a little bit of this script. But you see here we have some variables like, is it held? Is the string being pulled? Do we have the triple shot bonus? You know, a couple other things, the length of the pull. I'll go into more of those later. But as you can see here, this is the begin overlap, so the bow kind of handles its own state. So it's basically, if you first come up to it for the first time, it's not held. So if there's an overlap, it's going to say, is it held? No, it's going to follow this white line. So then it's just going to return. And this always replies because that was just a dummy Boolean to make sure that it's hooked up before doing any attachment and,
Sure.
and getting log spam. So basically, if this was not held, all this does is returns, but it returns a selection MID. And notice here that I mentioned before that left-right was useful for different things. This is how the system works, where it highlights either the left or the right knock on the bow, which is going to just kind of tell you, are you grabbing it on the left or the right side based on which hand it was. And then also, it's another cascading thing where if the bow was already held, it shouldn't actually be called in that case. Oh, you know what? That's because it's going to pick from these nodes for this data return, regardless of which execution pin it followed. So this check here allows it to then override with either of the knock MIDs with the string MID, so that it just tells it to highlight the string if it was held. Sure. So that's a little hard to follow because held is false over here, but we're actually returning data, which is returned for all of the types. So if it was held, the only thing that happens is still returns and just returns this knock thing. If it was held, but the hand that grabbed was not the hand that was holding it, then what it's going to do, it's going to make the string release visible just to show you kind of you're about to grab an arrow or something like that. Sure. So that's all the logic for overlapping the hand. And then ending the overlap is very similar. It's going to make sure that before it does an end, was it the actual stored overlap actor? And that's just kind of a sanity check, because sometimes you end multiple overlaps that weren't actually the one you cared about, and you could log spam. And then just some more debug setting end overlap. And then we set overlapped actor to null, which that is how it works nicely with this is valid check. If it's null, it's going to follow the is not valid, which is what we want to allow more stuff to happen. So we null that variable out. And then all that happens after this is that we remove the selection highlight. And so this is checking, was there actual stuff in the array? If yes, we remove the highlight, and then we clear the array. And removing the highlight is the same as the other function, other than it sets value to 0, which, thinking about it now, that could have made that an instance of the function and just had an input value, like set selection highlight. But yeah, I guess you always see things you can optimize. Not terribly important. So that's pretty much showing the entire overlap setup for how you start to interact with the bow. And next I'm going to show the actual grabbing and then the script of the bow itself. So first I'll show a couple of these things in the bow, and then I've got a copy of the bow where I've deleted most of it, and I'm going to just recreate some of it from scratch while looking at a copy on my end that you guys can't see, just so that I don't mess anything up. So I've showed you guys the overlap part. So the parts that we haven't shown yet are the overall script and the things that happen in the interface. And that's pretty much all that's happening here. So the actual event graph, it's pretty lightweight here. All it's going to really do is on tick, if you have an arrow knocked and you're pulling the string, which is true, then it's going to adjust the string pull to position the arrow in the right place, and it's going to calculate the length of the pull, which is how it decides the tension, which is how you decide the firing velocity. So all this is doing over here is, are we pulling string? Yes. Set the grab spot to be where the hand is, plus the offset of the initial grab, which we'll show in a second as well.
This is kind of determining how you're getting that arc, because that's actually a question that came up, is how are you determining that, that arc?
The arc is actually just physics-based, based on the velocity, and the arrow is set to align with velocity. But you'll see here, so when we set the grab point, and then we set the string to actually bend to meet the arrow. And the way we do that is we set a material instance dynamic parameter. We set it to be grabbed, and then we set the grab spot to be where the hand is. And that's what creates that nice solid kink in the arrow where it meets, or the string where it meets the arrow. And then we calculate the length. We set the set the arrow transform to be based off of the grab locations, which again, this works like we've seen some of the other things, is the holding hand left or right. And notice that this is actually, so it gets the knock. So that's how it's actually figuring out the arrow. So it gets the grab spot is where your hand is grabbing it at currently, and this is the knock. And so it gets the angle between those to come up with the direction of the bow or the arrow. And so then normalizing that converts it into a unit vector. And you notice here I do this little offset. This is a bit of a hack, and I'll show you the arrow to show you why. So The arrow is also pretty simple. All it does is tell a target that it hit the target. It doesn't do anything otherwise. And then it does, this isn't even used. It's some old material stuff. So all the arrow does is tell a target when it hit it. But I'll show you in the graph how this is made. It's literally just a collection of boxes. At its core is a box component, but because we cannot offset the location of the box, it's always at 0, 0, and the extent is 30. I actually tried parenting this to a scene that was offset so that I really want the origin of the arrow to be at the base. For some reason, doing that caused it to have no collision no matter what I did. So I just had to live with it, and I have to offset the arrow forward by 30 units, which is the extent of this box, which is half the box. So you'll notice that 30 anywhere in the arrow or the bow script is accounting for this 30 unit offset, where otherwise it would position the arrow at the center where you're holding it. Obviously, you need to position it at the end.
Yeah.
So we add that 30 units forward, and then to make the rotation or the transform for the arrow, we're setting that location with the offset. And notice that we make rotation from X, which is just a rotation made from the distance between these 2 points. So it's kind of, tell me A to B, point in that direction, and it shifts the arrow forward so that the end half comes forward to be at that spot. So that's pretty much all the logic for positioning the arrow. This is just some debug stuff which draws a line for cheating, which I'm not going to really get into. It just extends this straight line here much further, is all it does. And so this string tension part, this only actually does anything when you're not holding the arrow. So you'll notice here that pulling string false goes down here to string tension. And this actually is using a very basic spring physics macro solver, which causes it to bounce. And you'll notice we have dampening set to 0.5, speed is set to 40. And that's a really high speed setting, which is what gives it that feeling of intense, it snaps back quickly with a fast vibration, rather than if it was lower, it would be, lagging around. And we probably are not going to go into the details of this too much.
Is that an engine macro, or did you create this macro?
No, I created this macro.
Yeah,
it's
this is the part that was like,
it's a bit messy because it has to use these local variable vector types and then the assign node.
Okay.
But basically all it's doing is it's using the vinterp2 node to always overestimate the target based on the velocity. So the faster you're traveling, the more you're going to overestimate where to go, and then that slowly just converges. So you kind of oscillate past a target.
Yeah.
And by speeding up or slowing down what that overestimation is, you get different behaviors. And also dampening is kind of just making that velocity tend back down toward where it really should be to just smoothly go. So it's the reason it's not going to go too much into that is that at some point in the near future there will be a proper C++ solve of that, which will be a little bit faster, but the same thing. We refer to this as a data-driven physics piece. So this is like a data spring. It doesn't actually have any collision or anything. It just has a point and a target and some settings. And you notice up here I was talking about when you are grabbing the string, it sets the grab spot of the string MID to be where your hand is. All it does is it reuses that same parameter, but tells it where the bounce location is. So it's just when you're either pulling the string to perfect tension or it's bouncing. And the side effect of this is that the spring is always bouncing when you're just like dragging the bow holding it. It'll just be barely noticeable because you're not really snapping it with such a wide distance between its target and its start. And then so the other thing that this does is the haptics, which right now this is set up for both Oculus and Vive. This is the Oculus one, which is a bit more flexible. This is the Vive one, which I guess I lied before when I said that this works equally left or right. Right now, it mostly works with haptics, assuming you're holding the bow in your left hand. And the only reason for that is because our Vive force feedback integration is not fully featured right at the moment. So you end up having to make these left and right forces for everything, and I didn't create everything in inverse. I've heard that there was some other force dynamic, but I couldn't end up finding it. In fact, someone actually showed me at their desk, and I still couldn't find it.
Really?
Yeah, basically a way to play a force feedback on the Vive without specifying an asset. Because I've actually gone through and recreated a bunch of forces like a strength 0.1, 0.2, 0.3, 0.4, so that I can programmatically control the vibration. So this is just a quick thing that it does when you this is just nulling it out to be nothing, because otherwise with the Oculus you sometimes have a risk of letting an effect keep playing.
Yeah.
So this just kills out all that stuff if you're not pulling an arrow. So that's it for the event graph for the bow. The rest of it all happens in the interaction, the interface functions. So just to recap, the event graph just does pulling the string and the string tension. and positioning the arrow while you pull the string. So that's pretty much all the event graph does. The rest of it happens on the begin overlap, which is handling whether or not you're going to actually grab the thing. Grab pressed. This is basically whether or not you're going to pick up the bow when you grab it, or if it already was picked up, you'll start pulling an arrow. So you'll see here, let's assume we had just come out of begin overlap. So it's all it really did is highlighted the string or the knock for the hand to highlight. And now coming into grab pressed, if it's already held, it would grab the string and knock an arrow. If it's not held, it sets the holding hand to be the one that did the grab. It sets held as true, pulling string is false, pickup is true. And pickup, you'll notice, is actually a local variable inside of the interface that I've added. And the reason for that is because sometimes you'll want to return something with the interface, but it can be set differently from different execution paths. And this comes back to the way that data is passed differently than execution in blueprints. It's always going to return this variable. So I need to set this variable to be different states. So you'll notice in this top thing, I set pickup as true. Down here, I set pickup as false. Here I say pulling string is false. Here it's pulling true. So a lot of the times, these are just mirror images of each other in the two states. And that's because I just want to return one value. Or really all I can do is return one value here and then decide what to do with it in the hand. So go through that a little bit more. I showed grabbing the bow is saying it's held. We're not pulling the string. The item does pick up, which then goes into the hand and tells it to actually do the attachment. And if it's already held, it pulls the string. And it's very similar. It says the string pull hand is the hand that did this interaction. The string hand BP, and this is a copy of, or sorry, not a copy. This is a variable of type left hand, which just means it's another way that can get any of the properties from the hand that's holding it. And that's useful because maybe you want to get the sphere, maybe you want to get some setting, with, you know, but lets you grab anything. Tells it we're pulling the string, we're not picking anything up. And this is the part I mentioned before, initial string grab offset. I probably could have pulled this out, but this was added in here as a way to, so you can grab the string all the way at the extent of that sphere. You don't have to have your hand right on the string. For example, you might want to have your hand a little bit lower so that you're not blocking the visible arrow with your hand. This allows it to grab and then stay attached with that initial offset so that it doesn't snap it inside of the hand. An alternative way to do this would have been to add some sort of anchor point on the hand blueprint that's on the top and in front, and it just always snaps to that, which I probably would have done if I had more time. But this was set up to be a little bit more for polish or something. So it's, where is the string sphere? Which the string sphere, I'll go show the blueprint hierarchy for a second. And this is all, once again, made out of cone, made out of cone, made out of sphere, made out of, this is the only custom mesh. I made a bowstring, and the only reason I did that is so that I could make sure that there was a tessellation in the middle that I can, and then I have a vertex color gradient where it's 0 in the middle verts and white at the top, and that's how I control in the material where to reposition the middle vert. So that's how all the tension is working. It's a pretty simple mesh. I mean, I would show the wireframe, but it's probably too small to even get anything out of. Yeah, it's just a box with a tessellation in it. So you see here we have a couple things, like we have a string sphere. It's a little collision sphere at the string. We have a sphere for grabbing, and those are, they actually don't have any specific behavior to them other than useful for getting locations inside of the bow to check against and things like that. Yeah, so I guess where was I? I was on grab pressed. So string sphere, it's basically saying the hand location, which notice this hand is the same as this right here. It's basically saying how far was the hand from the string, and then it stores that as the initial offset. And we set the string release to be hidden now because we no longer care about it and don't want it to get in the way. And here's where we actually spawn the arrow. So that's the first major thing that happens here. After we've grabbed the bow, grabbed the string, it spawns an arrow. Notice that I don't even care about the transform. If you don't hook up a transform, you'll get a compile error, which is kind of silly. I don't care about the transform. Why? Because the event graph is always going to be setting it, so it's just going to fix it the next frame. Technically, I used to have some math here to make this spawn in the right location, but I deleted it for the stream. There may or may not be some side effects. And then we set the current arrow, which is, again, a variable we've made here, to be the spawned actor, and it's of type arrow. And over here we have this spawn bonus arrows. This is just, you guys saw that when you get a bullseye, it does 3 arrows. It's going to do the same thing, and it's, once again, it checks if we have the triple shot, which this only gets actually set by the shooting gallery blueprint, so it just gets set elsewhere. So all it really does is spawn 2 more arrows, and it stores bonus arrow 1, bonus arrow 2. Once again, doesn't care about transforms, it's all zeroed out. And then we set triple shot to false so that it doesn't do it again.
Yeah.
So that part is pretty simple. Let's see, that's pretty much it from here. And over here, it's just returning the transform of the box, which is the root of the bow, and the hand is going to use that to grab. It returns whether it's picked up, whether the string was being pulled. In this local grab location, not actually using this right now, but this is just a way of saying where in local space, if you had a specific thing you wanted to grab or whatever, you could pass that. And one example of that I think I gave before is a 2-handed bow staff, which I did another prototype that's not part of this project, but that was why that was added. So grab released looks a little bit more going on, but it's really not too much. Basically, it's a similar check. It checks when you do a release, was it the hand that was holding the bow? So if it was the hand that was holding the bow, basically drop the weapon. Yep. And that's just, held is false, pulling string is false, drop is true. Some older messing with overlap settings, not using anymore. And then once again, debug stuff to just say it was dropped. And then that passes back down to the release, which of course goes back to the hand to decide whether to drop or not. But if we did not drop, if it was not the hand that was holding the bow, then we check, we go through a sequence, which is just a way to quickly go back to the same output without having to hook up like the false to the return, because that's one annoying thing is if you have branches in these, you have to return every execution path to the return node. So that's, if you see sometimes that is the reason why I'll have a sequence before the branch, just so that I can not have tons of extra wires. So anyways, we check, was it the pulling string? And this is pretty much always going to be true, right? Because if you released, or sorry, no, that's not the case. Because you might not necessarily have actually successfully grabbed. You could have grabbed the bow or tried to grab and not actually knocked an arrow and then released. So this makes sure that that didn't happen. So if you're pulling the string, you're not pulling the string anymore. And here's the part where we actually fire the arrow. So once again, we are in grab release, which is an interface function, and this is how the arrow fires. Basically, it takes the arrow, which by default has a projectile movement disabled. And I guess it might make sense to pull up the arrow real quick, just to show where that setting is. So notice it has a projectile movement. Where is it? Okay, auto activate is false. So that means that the arrow doesn't do anything when you spawn it. It just sits there. So the way that we activate it is we set active, the projectile movement, and then we set the velocity in local space. So this is the part where we're kind of faking some physics here. So it becomes a real physics-based projectile once it's fired, but we need to give it some velocity. And so what I do is I calculate the length between where your hand is and where it started to pull, and that basically tells you how long the arrow pull is. And so I kind of modeled this off of a regular longbow, which has a draw distance between, depending on size, anywhere from maybe 25 to 40 inches. So I picked a nice average 35, maybe a little bit on the larger side. But basically, this maxes out the length past that, just so it doesn't ever get to crazy values. And it's basically making it like a cubic function. So it's like to the power of 3 changes the amount of velocity that you're going to get. And this was kind of hand tweaked to be so that a maximum pull was around 150 feet per second, which is a standard bow and arrow speed that you'll see for a longbow. A compound bow will go a bit faster. They get up to over 200 feet per second, but I didn't want it to go that fast because it already felt crazy fast full speed in VR. You want to be able to see the arrow, and the compound bows are just so fast you can't even see them. So once again, this is just taking that length, clamping it, making it into a cubic function, which gives it a very steep, very curved slope rather than just being a linear line, which wouldn't be very interesting. Sure. This makes it so the more you pull, the last few inches really matter. So if you just do a halfway pull, you're going to get way less than half of the force. And so notice that we apply all of that to x, and this is a local space velocity. And that matters because the direction that our arrow is in the world, I'll go ahead and select something. Of course, it happens to be in local space mode right now. Let me select something else. Okay, and it's not showing. There we go. So this is an unrotated component, and X is the forward direction of this blueprint. So if we want to fire it, naturally it makes sense to apply velocity in local X. So it does that. And also, rotation follows velocity. Without this setting, the arrow would literally, if you shot it slowly, it would go "eow," like that, rather than arching down.
Yeah.
So between local space velocity and rotation
sure
follows
that's
velocity,
checked.
it's a nice little physical behavior that you get. And then the last thing we do is we set the string release to be, what is this here? Oh, I guess this is actually some old code. It's removing a highlight or something like that, but it's not actually
setting its default, so it's
not doing anything.
highlighted anymore.
So it sets the current arrow to be nothing because that arrow is going to get destroyed soon, so we don't want to leave around a stale pointer.
Sure.
And this is also, remember before we had the spawn bonus arrows? Anywhere where we fire the arrows, we follow it up with a fire bonus arrows, which is pretty similar. It checks if bonus arrow 1 is valid, and then it does the same thing. Same velocity, same script, and then kills the variable. Then it does the same thing to bonus arrow 2 if it's valid. So these are basically just a repeat of that same script, but for the bonus arrows.
Sure.
So we've made it through pretty far right now, and I guess we're using up a little bit of time, but that's all right.
Yeah, that's fine.
So I was originally planning to recreate these scripts. I'm not sure if we actually will have time, because kind of going through them seems to be working all right. But if you guys want me to recreate any certain part of it, I can do that.
Yeah, there's a couple questions that came up too. Is it any gimbal lock issues when aiming up or down? Is a question that we have.
Not right now, because it basically attaches it to your hand, and you can rotate the hand any which direction.
Right.
Like you can hold it like a crossbow by going gangster style, turning your hand sideways, which is kind of actually better for this wide shooting gallery we have, because if you hold it vertically, you're obscuring a lot of the battlefield. If you hold it diagonally or sideways, you can really, turn left to right and not have your vision obstructed.
Yep.
So that part isn't an issue. Although I could see how it would become an issue if you were doing something like trying to set the rotation based on just like angles or something like that. We're using rotators. This is doing the attachments using transforms, which bypasses that. And I can show you guys a little bit of that as well. I may have missed a couple other things with the, so update bonus arrows in the force feedback. This is, again, in the event graph, which all it does is pulling string and string tension. But it also does update bonus arrows, which is very similar to the code you see to position the arrow, where it's getting just the relative difference between the knock and the grab spot and making it that way. This does the same thing, but for the 2 bonus arrows, with the addition of, where is it setting it? Somewhere in here I add, here we go. So I get a local space z vector here, which is 0, 0, 5, and I just make the rotation with that 5-unit offset in z, and then the other one is a negative 5-unit offset, so that creates the spread. And on my to-do list that I never got to do was make it so that maybe the right D-pad, if you touch the bottom or top, it would either increase or decrease that, so you could make the spread widen. Just never got time. So that's why right now, you actually, if you want to aim the arrows, you have to fire with less speed, because that'll change the angle. But there's no other way to control it. But you could pretty easily just make this driven by touchpad or some other thing.
Sure.
But yeah, this is the exact same code from before on the event graph. It's just we've added in this additional offset in local space, which this transform direction here, or actually this is getting from local space z, transforms it into world space. Because when you take a local space and you do transform direction with a actor transform, it makes it go to world space. So I think with that I've shown pretty much everything in here except for the updating the haptics. I'm hesitant to show that because it's a little bit hacky, which is funny. So the Vive or the Oculus one is actually pretty simple. It sets the frequency and amplitude based on some acceleration curves. So here you'll notice we have this length and previous length, and by storing the difference between them, we can actually figure out if we're accelerating or decelerating. So that's how we can do, like, you won't be able to tell unless you actually play it, but when you grab, it goes,
You can feel it.
or if you grab, slowly, it's, that sort of thing. So it adds a little bit of pitch based on acceleration and the overall length. So it's going to get a little bit higher pitched toward the end of the pull, even if you're slow, but it's still going to be higher pitched based on your velocity. And then it does kind of the same thing for the Vive, but I had to wrap it in some additional logic. because basically I didn't have the ability to specify the exact force feedback with parameters. I had to use assets. So I basically made the assets really short. They're like 0.1 second or 0.05 second duration. And then I make this timer, and I make sure that I keep re-triggering this every time the timer is over a limit. So you'll notice here this time accumulator, I always check if it's greater than 0.1, which means there's going to be a little bit of gap between the sounds, which gives it that kind of textural feel.
Sure.
It plays the sound, and then it subtracts that accumulation, which this is very similar to fixed time step. If any of you guys have messed with fixed time step stuff before for physics or whatever, you do something like this where you accumulate and then subtract the interval. And so you'll notice here, this is kind of a hack, I guess, but I have an array of force feedbacks. Where is that? And like I mentioned before, I made this array, and this is kind of silly. I made actual assets for the intensities, like 0.1, 0.2, all the way up to 10. And then by getting from the array, so I have the, basically the frequency that I want, I order those in order in the array, and then by multiplying a normalized value by the length of the array and flooring that, I can now look up into that array to get a force that matches the input. So kind of a hack, but it allows me to do a bunch of different stuff. And this is just calling a force feedback on the controller every 0.1 second, and with the sound that matches this parameter here, which is loosely based on the both the length of the pull and the velocity of the pull. And you can see here at the very end, I do previous length is length. That's just a simple way. If you look at anything that's like tracking velocity, you'll always do something like this, where at the end, you store previous to be the current. So that now once we go over here, length has been updated by the rest of the script, but previous length is still the previous frame's value. So that's just a simple way to do that. So I think at that point, I've kind of shown everything from the script in terms of where the different things happen. I may have left something out, but in case I have, you guys feel free to post on the questions or whatever.
Yeah, they're one of the, not necessarily a question, but a comment, the play dynamic force feedback. That might be the node
you know
you're
what?
looking for, maybe?
I thought I looked for that and could not find it.
Is it context sensitive? You want to check that?
Yeah. That'll be funny. So I may have done all that work for nothing.
There it is.
There it is. I don't know why I could not find this node. I swear I looked for it for like an hour the other day. All right, so yeah, you can forget everything I said about the array hacks and stuff like that. You can just do it this way.
And then you can
And some
specify.
additional notes. Right now, since we don't actually have, you'll notice the frequency and amplitude. Nick Whiting, our VR programmer, has kind of hooked this up right now so that large and small, I think large is frequency and small is amplitude. So these are not actually large and small motors. They've been kind of hijacked.
Yeah.
So that's how you would, I guess, make this behave the same as the
Same
Oculus.
way, yeah.
So yeah, thank you for that comment. I swear I was looking for this node. I guess the context thing just threw me off.
Yeah.
So that could all be simplified.
Can you show the material for the string? Are you
Sure.
just using world position displacement for the middle part of the string?
Yep.
This is one of the things that I found most interesting about this project, was how you set this up.
So bowstring, wait, that's a mesh. I guess it must be on here. Oh,
Yeah.
it's a default material, so let me look at the blueprint once more. Bow. String mesh. And always deselects. That always gets me. Where is it? I'm blind here.
That one. maybe.
Okay, so it's just string. So some extra stuff in here. Let me clean that up. Let me
Yeah.
just clean this up real quick. So yeah, there's not a lot going on. This is the selection glow I was talking about, which is just an emissive color. Everything is happening here in the world position offset shader, which is the vertex shader. So you mentioned, or I guess I mentioned I used vertex colors, but actually what I used was UVs. So, okay, here we go. Getting there. All right, so this here, where we do world position, 0 minus world position, this is essentially saying subtract these verts to the origin of the world. These verts start at 0, 0, 0. You could also do times -1, doesn't really matter. In fact, that might be slightly cheaper. So what that basically means is I can go between verts. I can literally control their offset. So I guess I can see some ways I could have made this a little bit better. But right now I'm pretty much reprojecting the mesh using the first UV channel, which I think I've done is a top-down kind of UV channel. And this just makes it so that it's not literally collapsed to a point. It adds some thickness back to it along the R and G. But really what's happening is this part's just adding some thickness. And this part is the actual world space location of the grab. So by adding the thickness to the grab and adding these both from 0, it means that it's a direct position rather than an offset. And this multiply down here, what's going on? Oh yeah, so this is whether or not, if it's not, this basically allows you to disable this with a single parameter if you want to. I don't think I'm really needing to use this right now because the tension just kind of takes over and moves this as necessary. So you could probably, just bypass that. And so this UV channel, the green channel, if we were to go look at that mesh now, which now I'm curious what I did for that. Like I said, I did this mesh over a year ago. Yeah, so I think what we're seeing here is that it's actually, I split this string mesh in half vertically, and then I flipped the UVs on the top half so that both of these are 0 at the same place, and both of them are 1 at the same place, if that makes sense. So I have a 0 to 1 gradient. In fact, you know what? It'd be easier just to show it if I go back to that material, and if I just hook up this to emissive, actually base color, and let me set specular to 0. You should see the white in the middle, basically. Oops. I'm not used to docking things so much. Sorry. Oh, man. Yeah, I'm not a docking person. All right, so, of course, we... Oh, hang on a second.
Probably see it in the viewport, too, the blueprint.
It looks like it's 0 to 1 going all the way from the top to the bottom, which is odd. Oh, you know what? It's because grab spot. It's actually doing the grab spot down to 0 or something. Hang on. That should not be doing that. It's because I didn't disconnect it. Let me disconnect world position offset. This will be more clear. There we go. So you can see white in the middle, black at the base in the top. So that just gives me a gradient where I can just pull around those verts.
That's awesome.
So technically this probably has some weird twisting issue because it's not transforming this back into the local space. But, I haven't seen it. So it could probably be slightly tweaked or made better. But yeah, it's a pretty simple little material that just relies on the blueprint, just data driven. And the reason that's kind of nice is just because you don't have to have any, separate physics or tools hooked up or anything. It's just a simple little trick.
Yeah.
All right, so I see a couple other questions that have been added in here.
How do you aim the bow in game? Rotate the bow hand, or is it based off your arrow pull hand?
It's not, it is based off your hands implicitly, but it's really based off of, looking down the arrow, to where you want the arrow to be almost a dot instead of a long line. It's just like firing in real life where you can either try to use both eyes or close one eye. I tend to close one eye while I'm shooting.
I think it is a combination of both actually though, because you can with the bow kind of aim it, and then with your right hand you can kind of pitch the arrow in.
Yeah,
in
for
your
sure.
hand.
But if you want to try to get a bullseye, you're best off trying to look right down the arrow to get it to be a dot. But by the end of that little shooting gallery, you're pretty much shooting from the hip because it's so fast. And that's when you're just, literally from the hip, just trying to get your shots off. So you can kind of just explore those different possibilities.
Yeah, let's see.
We'd like to make this available to download soon. I don't know exactly when, but there's nothing holding it back, I don't think. Maybe.
Yeah, that's something we could talk to our team and see how we can distribute this. But yeah, that would be a good thing so people can kind of pick it apart. It kind of segues into the project that I based off of your project. Because I just followed your setup pretty much and was able to get something up and running.
So will the input system ever allow multiple actors to have input enabled so we don't have to pipe input like what is being currently shown? You can do that right now. You just have to say don't consume input, and then you can get the input in your multiple places. Personally, I don't like to do it that way. I feel like it gets messy, and you can't discover where input is being done. I feel like it's pretty important that you should always make it a rule that all your input happens in one place, and then you decide where to put it. And that's why I think interface is a good way to do that, because you can quickly decide if functionality is redundant or just needs to be recopied over. But yeah, I guess I can kind of see what you mean. Sometimes it is painful to do it all that way, but it's not like it's in C++ where you can just search the whole project for this node.
Yeah,
like
it's really hard to discover it when it's checked.
I've screwed myself a few times by refactoring what I thought was clever by putting all this inputs everywhere, and then it becomes a nightmare tracking down where all your inputs are. So for that reason, I would recommend not to take that approach.
I think
material
that's
for the string. I think we hit most of
I
these
think we hit
things.
most of these,
If
yeah.
anyone else has any last minute questions, otherwise I guess we can start switching it over to show off Wes's cool little tower defense finale that he made, which is
Yeah, it'll
pretty
be really
awesome.
quick because we're going to wrap up here. But yeah,
That's all right.
basically just took a look at Ryan's project and was able to reconstruct how he did it. So releasing this project is something that we'd like to do down the road so you can get your hands on it and kind of pick it apart and learn from it. Nothing fancy. I just kind of created a simple tower defense type of setup and popped it up real quick. Let's see. Close this out real quick. Let's don't see that. Hop off screen for just a second. And if you guys have any additional questions, just go ahead and throw them in the forum post for this stream, and we'll try to get to those as well. So it might load off screen here. Just a second.
Yeah, bear with us. It's always tricky to get the Vive to show up correctly when we have multiple screens and boxes going on.
Yeah, that's what kind of happened to us last week when we were trying to get our stream going. Had too many monitors. Anyway, so here's a project that I created. It's pretty simple, just using some Infinity Blade assets. Figured something that you can do with the archery mechanic that Ryan has created is create like a simple tower defense setup where you're on top of a tower, waves of enemies coming at you, and you kind of defend against them. There's no scoring system in it. It's very rough. I did this in like little over half a day. Set up the animations and all that stuff just to kind of get it to work, to illustrate what you could do with this project once you get your hands on it. So we can take a look at it. I'm going to play in VR real quick. It's going to make our screen go black for a second. Bring this up. And then
Do the move trick.
Did I actually click on it?
I don't think so. I think the compositor.
Yeah, compositor screwed it. There we go.
There you go.
And then let's just kind of position it so you can see it a little bit. There we go. And then let's get the compositor back.
All right.
There we go.
Awesome.
So kind of take a look at this real quick. All right. So this bow should look very familiar. It's kind of what we were just talking about. And I rebuilt this from scratch looking at Ryan's project. So like I mentioned, once you guys get your hands on it, you could do the same thing and tweak it as you'd like. But basically, I would grab his bow set up and then kind of fire over the wall to signify that you're ready. There's no like real mechanic. There's a lot of placeholder stuff in here just as I was testing it out. Like I said, I only had about a half a day to do it. So I can fire up and signify that I'm ready in that little trigger box up there. Some guys will start coming down and just use some Infinity Blade assets that were available for free off the marketplace. So I have like a little spider that'll come at me and I can kind of hit him and he reacts as I hit him. Can kill him. Interesting travel mechanic. We can kind of go to the different towers over here just by shooting into them, and that will pop me up so I can kind of come down here and shoot them from the top. So they're going to come and try and break down my little wall here. I didn't get to flush out as much as I wanted to, but kind of shows what you can do with them. And they don't try to attack me yet, but once you kill enough of them, a bigger guy will spawn that you can kind of try to take out too. So it's just a fun little mini game that you can kind of create here. It's pretty simple. And they all play hit reacts and do different animations and stuff. I'd like to have my triple bow right now. I didn't actually implement that just yet, but that would help me right now. So I can fly over to the other side and shoot them on this side too. So there's no wind conditions or anything like that just yet, but kind of shows what you can do with this mechanic. So we would like to get this project out to you. Don't want to quote any time frames on this just yet. I'll have to talk with our team and see how we can make this available and what's going to be the best way to do that. So we'll have an update for that a little bit later.
It's pretty cool though. It's like a little Lord of the Rings Legolas
Kind
fantasy
of,
mission.
right?
All we need is the guy with the torch who's going to blow up the wall.
I thought I
that
was
might
doing
be a
that
little
too, like
too
having
literal.
like the particle effect. You just dip the bow in, now you have a fire bow, and you can fire
Hey,
and
there
catch
you
things
go.
on fire. It'd be pretty fun.
Yeah.
So right on the nose, it's about 3 o'clock. I think that's actually going to do it for this stream. I want to thank Ryan for coming on, taking the time to show us his project. It's really cool stuff. If you guys have any additional questions, feel free to drop them in the forums. We'll take a look at those and try to answer those if we can. I guess that's going to do it. Unless you have anything else?
Yeah, no, I mean, thank you guys, and thank you, Wes, also for helping work on some cool other alternate stuff with this and coming on here with me. So it was a lot of fun.
Yeah, it was. All right, guys. Thank you. We'll see you
Thanks
next
a lot.
time.